Hello, everyone. Today we are going to talk about exponential functions. Before we start doing this, I want to make a little review about laws of exponents. I'm going to make kind of two columns. One is going to be example and one is going to be the rule, okay? So column number one, example. Here is going to be the rule. Okay, I'm going to start with a simple example. If you multiply 2 to the power of 2 by 2 to the power of 3, we actually mean that we kind of multiply 2 by 2 twice here and 2 by 2 by 2 3 times here, right? This is 2 to the power of 2 and this is 2 to the power of 3. Now in total we have 1, 2, 3, 4, 5, 2. So it's 2 to the power of 5. If you compare 2, 3, and 5, you're going to figure out that 2 plus 3 equals 5. So when we multiply functions with the same base, 2 is called base, right? And the little 2 is called exponent. We are going to add exponents and keep the base. The rule is going to look next. A to the power of s multiplied by a to the power of t equals a to the power of s plus t. So you add exponents if the base is same. That's going to be rule number one. Rule number two. We have 2 to the power of 2 and we raise it to the power of 3. You see the difference? There we were multiplying before and now we are raising power into the power. So what is going to happen? Well, first, power of 3 here means that you are going to have 2 to the power of 2 by 2 to the power of 2 by 2 to the power of 2 multiplied 3 times, right? 3 times. Now, each 2 to the power of 2 is 2 by 2, right? So we have 2 by 2, 2 by 2, and 2 by 2. Altogether, we're going to have 2 to the power of 6 because there are 6 2's, right? 6 2's. Now, what is 6? Actually, 6 is equal to 2 to the power of 3. 2 multiplied by 3, sorry. Okay, I'm going to write down one more time. 6. Why do I copy it second time? Give me a second, guys. Where is it? It's 2 to the power of 2 multiplied by 3. 6 is 2 multiplied by 3. Why it's 2 multiplied by 3? Well, if you look at the construction of this expression, we have 3 times the same expression of 2 to the power of 2. So we repeat actually double 2's 3 times. Basically, it's kind of, we are just counting these two. The rule is going to be next. A to the power of s and to the power of t. Sorry, my computer sometimes thinks that I'm making a circle. It's going to be a to the power of s multiplied by t. So when we raise power to the power, we're going to actually multiply powers and we add them in the first rule. Rule number 3 I want to review is what we do as a product. If you have 2 multiplied by 3 to the power of 3, for example. How do we open this? Well, we know that 2 multiplied by 3 is 2 by 3. And the power of 3 means that it's 2 by 3 multiplied 3 times, right? 3 times. Now, how many 2's we have? 1, 2, 3. 2 to the power of 3. How many 3's we have? Also 3, right? So it looks that this 3 was distributed over each factor of the product. The rule is going to be next. A multiplied by B to the power of s equals A to the power of x multiplied by B to the power of s. Okay. Well, next rule is going to be just like, it's not going to be actually the rule, but example. If I put 1 to the power of 5, for example, I'm going to have 1 multiplied by 1 multiplied by 1 multiplied by 1 by 1, right? So it's still 1. So the rule is going to be 1 to any power is equal to 1. Okay. Now, guys, this is not the rule, but it's rather a convention. And I'm going to first write it down over here. I'm going to write down that any number a to the power of 0 is going to be equal to 1. And here a it's a positive number greater than 0. Any positive number a to the power of 0 is set as a definition equals to 1. For us, it means that, for example, 5 to the power of 0 is going to be equal to 1. Here, we don't go from the example to the rule, but we go from the rule to the example. And the last one, negative powers. So, for example, we know that 1 over 2 can be represented as 2 to the power of negative 1, right? So basically, general rule is going to be a to the power of negative s is the same as 1 over a to the power of s. So minus in front of the power means that you move the whole thing in denominator. Okay? Now we are ready to move to definition of exponential function after we reviewed these rules. So exponential function. What is exponential function? Exponential function, it's a function f of x, which is equal c a to the power of x. What is what here? C is a coefficient not equal to 0, real number. A is a base of exponent. Normally, guys, we are going to assume that a is greater than 0 and not equal to 1. Well, we remember that 1 to any power is equal to 1, so formally we can plug in 1 here, but makes absolutely no sense because it's going to give us a constant. Okay. Well, we are going to do a couple of examples. Example number 1, y equals 2 to the power of x. So over here, c equals 1, a equals 2. Now, guys, I'm going to graph this function using a table. I'm going to build a table and graph the function. So table is going to have x here and y here. And I'm going to start with -1 and then 0 and then 1 and then 2. So these are my x's. So 2 to the negative 1, 2 to the negative 1 is equal to 1 over 2, right? 2 to the power of 0, we just remember that it always equals to 1. 2 to the power of 1 is just 2, and 2 to the power of 2 is 4, right? Well, I'm a little bit like scrambling the position of the value, but just like I want to do calculations. So now I'm going to graph the points I just calculated. Sorry, my straight line is not exactly straight. So this is going to be a typical graph of exponential function. We're going to do x here, y here, 1 unit here, 1 unit here. And I'm going to start with point -1, and that's going to give me 1/2. At point 0 is going to be 1. At point 1 is going to be 2. And at point 2 is going to be 4, right? And I'm going to connect these points with a smooth curve. And that's going to be a typical exponential function, 2 to the power of x. Okay. What is interesting, guys? We already know about horizontal asymptotes. Horizontal asymptotes happens when x goes to infinity and function is approaching a straight line. Here, guys, horizontal asymptote is going to be this line. Why? Because if I start plugging in smaller, like bigger and bigger negative x's here, like for example, what is y if my x is -100, sorry, even -10, 2 to the negative 10. What is 2 to the negative 10? That's 1 over 2 to the power of 10, or 1 over 1024, approximately 0.000 something, maybe 9, a very small number. So actually, bigger number I have here, further I go to negative infinity, closer y is becoming to 0 as x approaches negative infinity. So y equals 0 is a horizontal asymptote for this graph. Horizontal asymptote means that we are kind of going to use a dashed line to graph it. Okay, now here we investigated a function with the base 2. 2 was greater than 1, right? Now, guys, why don't we investigate a function with a base less than 2? For example, we graph another function. I'm going to use a different color. Y equals 1 over 2 to the power of x. What I'm thinking, guys, we already know transformations and other stuff. Of course, we can do this graph by doing points, but because we already know transformations, maybe we can try to use transformations. For example, what is 1 over 2? 1 over 2, we know already is 2 to the negative 1, right? To the power of x. Power and a power is just multiplying power. So we're going to have minus 1 multiplied by x, or 2 to the power of negative x. Well, guys, I don't know like if you still remember this or maybe not, but what we usually do when we have negative in front of the argument, when we have negative in front of the function, we are doing reflection about x-axis, but negative in front of the argument is reflection about y-axis. And well, let's try to do this reflection. I'm going to actually use the very same graph. So reflection about y-axis means that this point will go over here. This point will go over here, like a reflection, right? This point is going to stay because it sits on y-axis. And all these points which are getting closer to this side of x-axis are going to get closer over here. So now I'm going to graph. So that's going to be 1 over 2 to the power of x. Well, guys, if you wish, you can do the table and check actual values. Are we going to have the same values? But I think it's kind of obvious from transformations, but again, depends on how much you remember transformations. Now, guys, what is interesting? This function actually goes to 0 when x is going to positive infinity. So x goes to positive infinity, y will go to 0. So y equals 0 is a horizontal asymptote too. Horizontal asymptote. Okay, just on a different side, right? And you see that when x goes to negative infinity in green function, y goes to 0, but when x goes to positive infinity, y over here goes to infinity also, right? For blue function goes to 0, y goes to 0 here, and y goes to infinity here again. So we have two infinities and two zeros, and they happen on opposite side of x. Okay, so now, guys, what I want to do, I want to discuss a little bit how we graph transformations. But before we move to transformations, let's try to do a couple of problems on our own. So I'm going to set up problems. So graph 1, y equals 5 to the power of x. 2, y equals 1 over 3. Why don't we use 1 over 5 just to make sure that everyone is getting this reflection thing? 1 over 5 to the power of x. Okay, I'll give you 5 minutes, but myself, you can just stop video and I'm going to just count to 5 and solve actually the problem. Okay, so 1, 2, 3, 4, 5. Well, what I'm going to do, guys, I'm not going to do the table anymore because I kind of basically know the values. So I'm going to start with my first function. So I know that at x equals 0, it's going to be 5 to the power of 0. It's going to give me 1, right? And at x equals 1, it's going to be 5. 1, 2, 3, 4, 5. So next point is here. And I know that it's going to approach the x-axis near negative infinity. So that's my graph. Normally, guys, for the graph, you just need 2 points and knowing that we have horizontal asymptote over here. Okay, and that's going to be 5 to the power of x. Now I'm going to graph 5 to the 1 over 5 to the power of x, which is going to be what? 5 to the power of negative x if you modify it, which is going to be a reflection. So I'm going to reflect this point. This point is going to stay here. If I reflect this approaching part, it's going to approach x-axis on the right, that's going to be 1/5 to the power of x. I'm supposed to go through the point. Also, these are my graphs. Again, they're reflection of each other. Okay. Now, let's try to use transformations to make more complicated graph. Transformations. Well, we know that we have kind of several types of transformations. I'm going to consider first shifts. So 2 to the power of x plus 3 minus 2 shifts. So guys, what kind of shifts we see? Well, we see subtraction of 2 from the whole function, means that 2 units down, right? And we see addition of 3 to x. We know that addition of 3 is 3 units to the left. So basically, what you need to do, you graph, normal graph, 2 to the power of x, and then show transformations. X here, y here, 2 to the power of x goes through 1 and through the point of 2, right? I'm going to graph a dashed line to show that this graph actually like not what we are doing, right? Now, I'm going to do transformations. Transformations are 2 units down and 3 units to the left. I'm going to watch this point. So I'm going to move this point 2 units down and 3 units to the left. Now, what is going to happen to horizontal asymptote? Asymptote will go just down. If you move asymptote to the left, it's still going to stay same asymptote because you're kind of not shifting it in vertical direction. Vertical direction is just 2 units down. 2 units down is going to give me something like this. Now I'm ready to graph. By the way, where this point will go? This point will go 2 units down and 3 units to the left, somewhere here. Now I'm just going to graph the function. So, well, I was watching this point, that's 2 units down and 3 units to the left. And the asymptote is supposed to be on the graph. I did not label 0 anywhere on my units, actually. This is 1. Well, this is also 1. Okay, well, that's how we deal with transformations. We can have a minus in front of the whole function, which is going to reflect it, right? I'm going to graph one more transform function and then move to solving problems. So y equals minus 3 to the power of x plus 1. How do we graph this one? Minus is going to be a reflection about x axis. 1 is going to be shift up. I'm going to graph it over here, okay? So that's what I'm going to do. I'm going to first graph 3 to the power of x. 3 to the power of x goes through 1 and also through the point 1, 3, right? And has asymptote. That's my graph. That's my kind of original graph. Now, what I'm going to do, guys, I have a vertical shift up, which is going to give me like my horizontal asymptote over here. And I have it and have a reflection. I think I'm going to do reflection first and then do vertical shift. So reflection is going to be something like this. And over here, a reflection about x-axis, right? Reflection. Now I'm going to take this reflected curve and move it up 1 unit. So it's going to be something like this. You guys always can watch the 2 points which you are using, this and this. That's going to be the graph. The red one is minus 3 to the power of x plus 1. Okay, let me label the axis and move to solving word problems. Give me a second. I'll find them. Okay, guys. What is interesting in this section, we are going to have some word problems and they're going to be about interest. Interest is happening when somebody invests money in a bank or somewhere like where he gets percents after a certain amount of time. Okay, let me shift this everything up and write down interest problems. Guys, what is what here? When you bring money to the bank, this money are called principal, P, principal. Also, bank is going to give you I, interest rate. And after a while, like after 1 year, the bank is going to return you a little bit more money than you brought in, right? So how bank calculates a value returning you? Well, I'm going to put actually over here annual, because interest rate not necessarily is going to be annual. Sometimes it's daily. So guys, how bank is going to calculate amount of money on the account after a while? Amount of money is going to consist out of the principal, the money you brought in the bank, plus principal multiplied by percent rate. That's kind of extra which bank gives you for using your money. And if you simplify this formula, you are going to find that it's P multiplied by 1 plus I. You're taking P outside of parentheses, right? And I'm going to write down that's 1 after 1 year. After 1 year, you can take money with you and stop working with this bank, or you can kind of say, okay, have my money for a longer time and kind of keep giving me extra portion of money. So what is going to happen after 2 years? I'm going to show you once calculation after 2 years. After 2 years, because you are investing now this amount, you are going to have this amount plus what you invest, 1 plus I, multiplied by percentage rate I, kind of additional portion after second year. I simplify this expression, considering that this one and this one is the same factor. I'm going to take it outside of here, and that's going to leave me 1, and I'm going to get the formula, which is kind of similar to the first one, but going to have a different power. And from this formula, it's already clear why the problem sits in this section, because it looks like that's going to be exponential function, right? Well, guys, we can predict that after n years, imagine that we have n years, we're going to have principal 1 plus I to the power of n. Like every year is going to add 1 more parenthesis, 1 plus I. Well, this is just called a simple interest formula. And why don't we try to calculate something? So I'm going to let me kind of set a problem. Let's imagine that somebody is bringing, so the problem somebody is bringing amount of 1,000 to the bank, and the bank gives 12% annual rate, and you are keeping it for 3 years. So what is going to be the total amount on account? I'm going to write down the question is A after 3 years. What is going to be after 3 years? Well, we're just going to use the formula. So A after 3 years is going to be your principal, 1,000, parenthesis open, 1, interest rate, guys. You know that percents actually a different way to write down 1 over 100. It's just a shorter way. So that somebody get rid of 1 and put the zeros, 2 zeros kind of across the division bar. So actually, when you write down 12%, you actually mean 12 by 1 over 100. And if you divide 12 over 100, you're going to get 0.12. You don't need to do always this kind of multiplication over 1 over 100. You can just kind of move the decimal point 2 places to the left. Formula has it in parts of units, not in percents. Now, over here, the power is going to be like 3, because it's 3 years, right? And that's going to be final amount on account. I'm going to do my calculations using my calculator and give you the number. Give me a second, guys. Trying to figure a calculator, find a calculator on my computer. cell phone. Okay, okay, 1.12 to the power of 3. 1.12 to the power of 3. So I calculated that final amount is going to be 1,404 and 93 cents. That's going to be the final amount on account. Well, bank gives percentage of the bank is too high, I guess. I don't think that there are banks which are giving 12%, but well, who knows? So this is called simple interest. Simple interest. Simple interest usually compounded once a year. Like bank gets your money, keeps it for a year, and then plug everything into the formula and gives you the final result. Now, guys, bank can do more complicated operations, and one of them is compound interest, not simple interest, more complicated interest. Imagine that bank actually calculates how much money you get, not once a year at the end of the year, but several times a year, like 2 times a year or 3 times a year. How the formula is going to change? Well, I'm going to write down compound interest. Well, I don't know. Let's imagine that bank is counting interest twice a year. How the formula is going to change? Well, bank is not going to give you 12% every half year. Bank is going to give you 6% for the first half of a year and 6% for the second half of a year. So right now I'm going to calculate the first half of a year. First half of a year is principal. 1 plus interest is going to be what? Your actual interest of 12% divided over 2. That's first half of a year. In the second half of a year, it's going to give you this multiplied like we did already by the rate, like which is half less. And you probably think, oh, what's the point? That's just going to give you same number. No, guys, it's not going to give you same number. It's going to give you a slightly bigger number. So after 1 year, you are going to have 1 plus I over 2 squared. Well, it's not going to be a very big difference after 1 year, but after 3 years, it's going to be a difference. So what are we going to have after 3 years? I'm going to write down A after 3 years. It's going to have this one repeated 3 times. So it's going to be P 1 plus I over 2 squared repeated 3 times. Remember, power and a power is supposed to be multiplication of powers. So I'm going to have P 1 plus I over 2 to the power of 6. If I'm going to calculate what I will have with the same problem where I was doing simple interest and see how much it's going to be bigger with compound interest. And again, here we combine interest twice a year. Yeah. So it's semi-annually. Okay, semi-annually. Again, this denominator depends on how many times a year you combine it. So if you combine it 4 times a year, so you divide percentage rate by 4, and you're going to get only like, if you combine it every quarter, you get a quarter of percentage rate. Okay, now I'm going to substitute my kind of problem numbers. 1,000 invested 1. My interest is 0.12 divided over 2 because it's combined twice to the power of 6, and just get the final number. So 12 to the power divided by 2 is 0.06, so it's 106 to the power of 6. Well, let's check what are we going to have in this case. So 106 to the power of 6, going to give me, multiplied by 1,000, 1,418 and 52. Now I'm going to compare these two numbers, this number and, I'm sorry, almost lost a number on the top, and this number. You see that, well, in general, the numbers are close, but this is 0.4, and over here we have 18. So this number is slightly bigger. What does it mean, guys? Well, if you decide to combine interest like 4 times a year, the number is going to be a little bit bigger. And if you decide to combine it every day, 365 days a year, is going to be even bigger. Of course, the final calculations are going to be a little bit more complicated, but more time per year you combine your interest, bigger number you are going to have. Okay. Okay, I think that's all for today. I'm hoping that you can do the homework. In the homework, guys, semi-annually means that you divide interest rate by 2. Annually, you don't divide it. And I'm going to write down the formula for compound interest just to make sure that everyone kind of get it. Formula. Principal, interest. I'm going to put T as a time of years. N is going to be times we combine interest per year. So how the formula is going to look? Amount on account as a principal. It's going to be 1 plus I divided by number of times per year you combine it. And here, remember we had this number N, because it was like 2 times combined, twice parentheses, and number of years. So it's N multiplied by T. That's a general formula for compound interest. Okay. Okay. So I think we can maybe solve something, or let's try to solve something. Let's try to solve something more realistic. I'm going to consider a problem. So for example, P is going to be 2,000. Interest rate is going to be 4%, and we are going to combine it quarterly. And we are going to have, I don't know, 5 years. The question is again, what is A? And again, you guys have 5 minutes, and I'm going to actually just solve it after I count to 5, okay? So according to my formula, how should I kind of find A? A equals 2,000, my principal, which is coming over here, 1 plus my I is actually what? 0.04, so 0.04. Divided quarterly means that N equals 4, because 1 quarter is 1/4 of a year. Quarterly means that 4 times a year. Okay, so divided over 4, and we need to multiply number, we combine it by number of years, 5. So I'm going to have 2,000. Well, here, if I divide, it's going to give me 0.01. So it's 101, sorry, to the power of 20. Well, again, I'm going to use my calculator. 101 to the power of 20. And I'll need to multiply it by 2,000, right? Because 2,000 is my principal. What I'm going to get 2,440.38 cents. That's going to be my final amount to answer. Okay, that's all. And please do your homework, okay?